Hello all, welcome back to Code Hub. Let us solve today's fourth problem of this weekly contest 326. And this was a pretty medium problem. And what is this problem states? The closest prime numbers in range given two positive integer left and right. Find the two integers nums1 and nums2 such that this nums1 is greater than or equal to left and it is lesser than nums2, and nums2 is greater than nums1 and nums2 is lesser than or equal to right. So and nums1 and nums2 should be prime numbers, that is the condition, and we have to minimize that difference. Nums2 minus nums1 is the minimum among all the pairs satisfying the above conditions. So return the positive integer array, answer nums1 and nums2. If there are multiple pairs satisfying these conditions, return the one with the minimum nums1 value. Else we want to return -1 if such numbers does not exist. So a number greater than 1 is called a prime if it is only divisible by 1 and itself, so that we know. So how can we solve this problem? If this left and right is 10 and 19, we can take all possible pairs and it may become a n square solution if we are taking this all pairs within the range and we are taking only prime numbers. But how can we solve this efficiently? I will give an example such so that you will get an idea. So if we take left as 3 and if we take my right as some 15, then what are the prime numbers which are between 3 and 15? The prime numbers are nothing but 3, 5, then 7, 11, then 13. Yeah, these are the prime numbers that are these are the only prime numbers that are between the range 3 to 15. These are 3, 5, 7, 11, 13. So this will be in sorted order. So if this will be in sorted order, if we take one number from here and if we take another number from this from here, then this becomes a huge difference. So clever idea is a clever idea in to take the minimum possible is nothing but the adjacent prime numbers. If we take the adjacent prime numbers, then we will get some difference, and such that we want to minimize our difference, so we will be taking all the adjacent difference and we will be keeping track in one variable. So that is what this problem that is what the approach I have used. So first what I have done is I have used a sieve of Eratosthenes function to take the prime numbers from left to right. So what I have done is I have called this sieve of Eratosthenes function, where I have passed this right, left, right, and this right is going to denote the n, and this left and right I am having the variable passed for this function, and I'm declaring a prime array. This is a standard function to calculate to know which are the numbers are prime or not. So this function is going to calculate the primes, and I'm also declaring a vector pp where if that number is going to be a prime and if that number is going to be lying in the range between left to right, then I will insert into my pp vector, and I'm returning that pp. So that is going to be my primes vector in primes vector. So once I have the prime numbers alone within the range left to right, what I can do is I will be calculating the adjacent pairs difference. So I have kept a difference variable which is going to be the maximum variable initially, and I'm running a for loop from 0 to n minus 1 p dot size minus 1. So I'm taking the adjacent numbers as ff and ss, and I'm taking the difference. If my difference is lesser than this difference, I'm updating the difference, and I'm also updating the f and s variable. So and I'm at the end of the day I'm returning this f and s. So it is pretty simple. We are taking the all the prime numbers and calculating the keeping track of the adjacent primes. So hope you like the solution and let me know in the comments. So it was a pretty decent contest, I would say, and all the best and very happy new year for the rest of the year and rest of the life, and all the best. Thank you.